Problem 162 wants to take a look at some exact values of these trig expressions, and we're to take a look at this when we have this domain. So what that means is if I look at the unit circle, anywhere between 0 radians and 2 pi radians, that's what that domain right there means. So essentially we're talking about one time around the unit circle. Can't go more than one time around the unit circle. With that, I need to locate each one of these. So if I look at the very first one, we are dealing with cosine of 3 pi over 4. So first of all, I need to look at what 3 pi over 4 is. My reference angle will be pi over 4. Looking at 180 degrees being 1 pi, getting a common denominator, I have 4 pi over 4. And then subtracting my reference angle gives me my angle in quadrant 2 of 3 pi over 4. It is a 45/45/90. And cosine is dealing with this side length. So this question is wondering what is that side length of that triangle. And that answer is going to be a negative square root of 2 over 2. So again, I need to know my triangles, my 30, 60, 90, and my 45, 45, 90 triangles. So then I go on to problem B. Start off with another sketch. So now I want to locate 4 pi over 3. So pi over 3 is my reference angle, which means at 1 pi, that's going to be 3 pi over 3. And now to get to 4 pi over 3, I'm adding a pi over 3. That is a 60-degree reference angle. So now with my 30, 60, 90, I have a cosine value of negative 1/2. That's opposite my 30. And a sine value opposite my 60 here of negative square root of 3 over 2. Both values are negative because I'm in quadrant 3. So for tangent, tangent is the ratio of the opposite, or the sine value, divided by the adjacent, or the cosine value. So instead of dividing by a fraction, I set this up as my numerator times the reciprocal of my denominator. 2 negatives make a positive. 2 divided by 2 makes a giant 1. So I get a positive square root of 3. So problem B equals then square root of 3. So then I'm going to start off with a new diagram for the next couple. Sine of 11 pi over 6. That means pi over 6 is my reference angle. This would be 6 pi over 6. But I'm going to need to go even further, and then 2 pi, getting a common denominator, is going to end up being 12 pi over 6, because 12 pi over 6 reduces down to 2 pi. Subtracting away a pi over 6 from there will give me my 11 pi over 6. There's my triangle. I have a 30-degree reference angle. That's my 60. Sine is talking about just this one side, the height. So for that one, my height is a negative 1/2. The next one, problem D. We've already located 3 pi over 4 in problem A. So if you need to look back at how I got that one, there's my 3 pi over 4. It was a 45/45/90. But now I want the sine value. The sine value will be that side length. So for this one, it is now going to be a positive square root of 2 over 2. Problem E goes back to tangent. And I'm still now talking about pi's over 4 as my reference angle, which means 4 pi over 4 is right here. Adding another pi over 4 brings it down to 5 pi over 4. So a 45/45/90. And on this one, in quadrant 3, I have a negative square root of 2 over 2 and a negative square root of 2 over 2 as my side lengths. Tangent, again, just like on problem B, the tangent is going to be the sine value divided by the cosine value. Since on this one they are both the exact same, and a negative over negative makes a positive, this is going to be 1. Tangent also, you might remember, is slope. So on this one, the slope of that is 1. So looking at problem F, I now have a little bit of a different type of radian measure. 17 pi over 6. So with pi over 6 as my reference angle, 6 pi over 6 right here, 12 pi over 6, as we talked about in problem C, is right there. That means 17 pi over 6 makes one whole revolution, which is again 12 pi over 6, and then has to go another 5 pi over 6. So when it adds 12 pi over 6 plus another 5 pi over 6, that's how we get our 17 pi over 6. So the location of that is going to be the exact same as a 5 pi over 6. So what I need to do now is I need to take a look at that reference angle. So I'm going to clean this up here a little bit. Looking right now, again, pi over 6 was my reference angle, 17 pi over 6, which means this is now a 30, 60, 90. Tangent, again, being the sine value divided by the cosine value. I'm going to then switch this to 1/2 times the reciprocal of the denominator. So negative 2 over the square root of 3. 2's make a giant 1 here. So now I end up getting a negative 1 over the square root of 3. Now for this I need to rationalize my denominator. I do not want to leave a radical in the denominator. So I multiply this here by a giant 1. And then with that, I am going to get my answer as negative square root of 3 over 3. The last problems then. We already kind of took a look at problem G when we did this one right here. And the answer here, so when is tangent going to equal 1? Well, if I have a slope triangle right here, there's my right angle. If I have the square root of 2 over 2 and the square root of 2 over 2, that's going to give me a sine divided by cosine of 1. So that's at pi over 4. But I also have the same thing as we talked about in this problem here in quadrant 3, because now both my values were negatives. So in both of those quadrants, either pi over 4 or 5 pi over 4, I get tangent to equal 1. So then, for the very last question, problem H, when is this going to equal negative 1? It's going to be the very same concept here. But now over here, when I have a cosine value that's negative but a sine value that's positive, but my side lengths are the same, so that's 3 pi over 4. Or in quadrant 4, where I have a positive cosine and a negative sine, which is 7 pi over 4, those are going to be the values that give me a slope of negative 1.